Alright YouTube, hello, thank you for watching. I started to do a video on this the other day and I ran into a bit of bad luck. This is an igbt driver that I made several years ago, and it was in a box. It got beat around. I pulled it out the other day and there was a couple of things broke on it, so I fixed it all up, powered it up, and I had a hell of a huge arc coming out of this thing. But I only tried it about 2 or 3 times. I didn't really see any problem with it. So I thought, okay, well, I'll put it on the table and spruce some other things up on it. So I did some other stuff to it. I was just ready to do a video on this, and I put it on the bench and powered it up. I got an arc out of it the first time, and then the second time, no arc. And I thought, man, this is kind of messed up. You know, I tried and it just wouldn't arc anymore. And then there was one time after that, which I think is kind of important to note, that it did. And then it's quit now, and I haven't been able to get it to arc for quite a while. My first thought was, likely what happened is I was flipping this around on the table, re-drilling this fiberglass G10 out, putting standoffs on it to make it stand upright. It got beat around a lot. This was flat down on the table. Some stuff got crushed down on it. So I thought the obvious thing was something broke somewhere. And I've been through this pretty darn good. I can't find anything broke anywhere. So here's what it does. So there it's drawing about 6 amps. Okay, and you think everything's going to be fine with it. Not the case. There it comes on, 6 amps. Boom. Little tiny spark, and then the amp meter just drops to nothing. Comes on, little tiny spark, shuts off. The scope is on the output of this astable oscillator, these two 2102s here that toggle back and forth. So this test point is seeing the collector of one of these, and the other test point is seeing the collector of the other transistor. Now, it's kind of funny because I said in one video, I said I like these astables because you just can't kill them. Well, something seems to be killing this one. Now, all that happens here is when you look at this, you got to kind of overlook a lot of stuff because it's got a lot to it. But it's actually very, very simple. So we are on one of these collectors. I'm not sure which. Really doesn't matter. So we power it up. So there it comes on. The amp meter goes up. You probably hear the little click. And you see we got drive to the gate drivers from that astable oscillator. But as soon as we try to arc it, boom, there goes our astable. It just shit the bed. That's very weird. The gate driver's set back here, so all this signal does is just go through that relay. Either that relay's on or off, depending upon what the voltage is coming into this. So the relay's just a break between this astable and the gate drivers back there. So we lose it at the gate drivers, and of course we lose it here coming out of this astable board. So why would that be? How could that little spark be shutting something down? That's the $1,000,000 question. And why did it not shut down before? Why did it run before? My theories are kind of this. I've checked all the voltage regulators on this, and the voltage regulators don't flinch. They stay at 5 volts. This voltage regulator over here powers the gate drivers, and it also feeds the voltage regulator over here, which feeds this astable. And both those voltage regulators stay up the whole time. What it seems like to me, and I could be way off here, but it almost seems like, you know how when you like get a ratty connection, like I've seen it with a fuse already. A fuse will work until you kind of put a load on it, and then all of a sudden it just completely breaks the circuit. Like you get a really high amount of resistance in a connection. You know, it works until other things need to suck current off of it, or until it's under load. Then it just kind of completely opens up, and puts such a high amount of resistance in the connection that the circuit can't work anymore. That almost seems like what might be happening here, like there's a bad connection somewhere. But I can't find anything like that. I am kind of curious here. Put that scope probe back on there. I wish my camera could see everything all at once. I mean, this is impossible to work on when you got a camera, because the camera can't see the unit, the amp meter, the scope, and a million other things all at one time. As soon as it sparks, it just takes a crap. So I'll put the scope probe on the power to the A stable. That's the 5-volt regulator to the A stable. Wow, that's interesting. That made me jump. I didn't expect that. The damn thing worked. For a second there, I had a hell of a flame coming out of it. I think there's a bad connection somewhere, and as soon as a circuit calls for current, whether it even be something minuscule like 50 or 60 milliamps coming out of something, it just says, no, I'm not going to do it. Basically disconnects. Let's just see. Back to the same thing now. If this circuit wouldn't have just turned on a minute ago, for no reason at all, I was just ready to conclude that there's something funky with the gate drivers. But now that came on momentarily there, I'm back to my same original theory, that somewhere there's just a hairline of a connection that's just not making the grade there. If this A stable isn't losing voltage, the gate drivers aren't losing voltage. The voltage regulator for the A stables isn't losing voltage. So the only thing I really know to do at this point is just to take another day and go through this again. Check everything, resolder everything, but I mean, I've honestly already done that. These gate drivers are a TC4452. And at some point in time when this started happening, I thought, I wonder if these gate drivers couldn't possibly be failing somehow, that they're impacting the line coming out of the A stable, making the A stable stop oscillating. And I thought, that's really far-fetched. The input of these gate drivers is like a MOSFET, which goes into a Schmitt trigger and the whole enchilada. And I thought, well, a part like this, if it's going to fail, it's going to fail. It's just not going to fail, when you try to arc something and then when you're not trying to arc it work. I mean, that just doesn't make sense to me. But anyway, long story short, I looked these up and there's two versions of these. There's the TC4452 and the 4451, I think. One of them is inverting, one is not inverting. Well, if you look at the data sheets for these gate drivers, you'll see these things are impervious to just about everything. There was at least 5 things in the description that told you it can handle all kinds of crazy conditions and just keep working. So I thought, man, I don't know, reading that, how could one of these things fail in such a way? I would think if they would fail altogether and that would be it. When I put the scope probe on here, that's when it worked for a split second. So this is the output of that 5-volt regulator, which comes over here onto that red and white wire, which goes over onto the A stable. That seems like the best place to start. Maybe when I put the scope probe on it, the force of the probe made something connect in there that I can't see. So one thing about these gate drivers, I'm still learning about them. These are huge gate drivers. I think these things will drive 22,000 picofarad worth of gate capacitance. So I replaced that little piece of wire over here, and now we have a whole other ball of wax now. This thing just keeps getting better and better. So my scope probe is back on the A-stable oscillator. And you can see we got an A-stable. Watch who you buy alligator clips from. I've been pulling my hair out I mean, these things don't even conduct electricity. I swear to God they put spray paint over these alligator clips. I really think that's what they did, because they're definitely not copper. So the A-stable comes up right away, which is what it's supposed to do. But now the problem is, wait for it to turn on here. When it turns on, we get nothing, no current draw. When that yellow LED goes off, that means it should be running. So now we got no current draw. So if we go onto the gate drivers now, the only thing between this A-stable and those gate drivers is that yellow relay right there. Relay clicked, nothing. Nothing on the gate drivers. So either that piece of junk Chinese relay, even though I can hear it pulling in, either that piece of junk relay is not making contact, or these gate drivers are, let's just say for example that the gate drivers were intermittently failing. If they were going to fail to basically essentially kill that waveform, we'll just say, basically short that waveform out, they would short it out over here too. If you follow what I'm saying, they would short it out right on the A-stable. They wouldn't short it out on the other side of the relay. Now I'm thinking I have a bad relay as well, but the relay has been working. The relay has been working for a long time, and it was never the issue. I'm not even sure what to make of this thing anymore. It's just one thing after another. And when I put this into the box, I mean, it didn't have an issue in the world. Got it off there. You see what I did is I surface mounted it. I think I did that because I knew if I soldered the relay in there, I'd never be able to get the relay back out. Here's the reason I think these gate drivers are bad. We put the plus on the gate and the minus on the ground. We get 1.373. We put the plus on the ground and the minus on there, we get nothing. Over here on this one, minus on the input to the gate driver is about 1.4, and when we put the plus on, we get nothing. There's a voltage clamp on the input to those gate drivers. It's like this. There's a 4.7 volt Zener diode there. So with the plus here and the minus down here, I don't think we should be seeing roughly 1.3 volts through those two junctions. If I look at another gate driver here, and of course that is in circuit, but there's actually nothing tied to the gates other than a 56K resistor. The rest of the gate is open through the relay. Now if we look at one of these here, I think it'll kind of confirm what I'm getting at. I think the first one is the input, the second one is ground. So we got nothing there with the plus on the input and the minus on ground. If we flip them, we still have nothing, which seems absolutely correct to me. So I kind of think that some part of that voltage clamp there, that minus 5 volt clamp, is no good. But the question kind of still remains in the back of my mind, why would it work 1% of the time? Why wouldn't it just quit and never work? Sometimes things are very, very deceiving. It's hard to figure out, well, you know, did it change because I did this, or was it just all coincidental? And this seems to be a big, huge case of coincidental with this thing here. But I will get it, no matter what I have to go through. When I looked back on my old video of this, I said that I put 150 hours into building this. That makes absolute sense to me. So that should go in there. Lengthwise, I think we're going to have just enough to maybe hold this board down to the heatsink through those two holes that are tapped into the heatsink there. Now I think what I'm going to do here is do some things that are a little bit different on the power supply line to these gate drivers. When I looked up the data sheet on this, it said these things are impervious to a whole lot of conditions, but it said that they don't tolerate direct overvoltage. You know, I find it hard to believe this was an overvoltage condition. on VDD, but I got some of these PK-P6KE 33As, some transient suppressors. I'm going to look up the data sheet on them. I got some mobs here too, but I think the clamping voltage on these is pretty high. I think it's up at like 53 volts. I don't have an awful lot of experience with transient suppressors and mobs. It's just something I've never really gotten into in my lifetime. But my experience with them has been they're great for a non-repetitive pulse, but as soon as something becomes somewhat repetitive, the things explode. That's about all I can tell you. So I need to get a ground down this side of the board and a ground down this side of the board, because there's a ground up here in this corner, and then there's that piece of solder wick coming down the side of that board. So my plan is to screw this board down through those two holes back there, and then solder all the grounds through on these board edges here. I think I got something here that might work. Kind of like so. Then those screw holes for those existing gate drivers are gonna fall right back in here somewhere. This one will go on the board. The one on this side, I'm not quite sure if it's even gonna happen. The IC sockets are on the board. I'm starting to get a little skeptical at this point. A couple hours later, I kid you not, this stuff is very, very time consuming. And it doesn't help that I'm installing parts on the top of a circuit board, so everything takes a lot more time to make sure that there's not any shorts anywhere. This is the input to the gate drivers there. This is the output of the gate drivers. And then I got a low ESR chip underneath this Panasonic film cap, which is a 0.1. And then I got two 2.2 mic tantalums all on the supply line, as close as I could really get them. I guess you really can't get them any closer to pin 6 than really what I've done there. Otherwise they'd be inside the chip. And then there's two 56K which hold the input of the gate drivers down, which is on pin 2. So I'm not using the out B, I'm only using the in A and the out A. Kind of a long story as to why that is. So there's actually two drivers on this board for one driver per MOSFET. Now these are capable of driving two MOSFETs out of one chip, but I can't quite do that because of the logic table. So I think I'm at the point here where I'm just going to have to start taking the other one apart. I've been putting it off, but I need two more 56K resistors on the input of the B here on pin 4, and I don't have any more 56Ks, so I have to salvage those two off of there. So that's kind of the next step, is start tearing that apart there.